Hello and welcome to inquiry activity number 3. In this one we are going to be looking at significant digits and measurements. So if you remember, we've been talking a lot about collecting data, organizing data. Obviously scientists are all about collecting information, data, numbers, taking measurements, recording those, and we're going to continue to talk about that a little bit in this video as we discuss this inquiry activity. So we're going to be looking at significant digits and measurement. Right here it says, and it's important to read all this information as you're working through these inquiry activities, which I hope you already have, and now we're looking at this video to just to see if you understand everything. So scientists do a lot of measuring, that's obvious. When scientists use an instrument, and that instrument could be anything from a ruler to a graduated cylinder or anything in between, some type of balance. You are going to measure something, and it is important to take full advantage of the instrument. We'll explain what that means in just a second. You can't fudge your numbers, or you can't cheat, or you can't, your answer can't be more precise than your instrument. So you can't record something that is a better measurement than your instrument is capable of. There is an understanding among scientists of the proper way to record valid measurements from any instrument. When you are the scientist, you must record data in this way. When you're reading other scientists' work, you must assume they recorded their data in this way. So it is an important method of recording data to use what we're going to call, what is called, significant digits. Again, we're going to look at models in order to kind of make a point as we discuss the importance of recording the data with the correct number of significant digits. Let's look at model 1. It is a ruler, and they've named it ruler A, and you'll notice the markings on this ruler are only at 0 and 10. That's the only place where it is marked. And we have an object right here that we are going to try to determine the length of that object using this ruler. 1, 2, 3, 4, 5, 6 people have tried to determine the length of this object right here using this very crude ruler, which only has markings at 0 and 10. And these are their estimated measurements or estimated lengths of that object. So we just kind of analyzed the model, we kind of made some observations. Now let's look at the beginning questions. What distances can be certain of on the ruler? Well, the only distances you can be certain of would be if something was at 0 or something was at 10. So 0 centimeters and 10 centimeters are your certain values on that particular ruler. 6 students, they are right here, used the ruler in Model 1 to measure the length of a metal strip. That's your metal strip as mentioned. Their measurements are shown on the right. Here they are. Were all of the students able to agree on a single value? No, of course not. They were not able to agree on a single value. But really more specifically saying, agree on a single value, 1, 2, or 3, for any digit. Ones place, tens place, etc. in their measurement. If yes, which value and digit did they agree on? So let's look right here. This is in the ones place, we've got 3, 2, 2, 3, 3, 3. So there's some discrepancy there. Most of them said 3, but a couple said 2. In the tenths place, this one said nothing in the tenths place, no tenths place in the digit in the tenths place there. This is 5 tenths, 0 and 0, 0 tenths, 0 hundredths. This is 1/4, that would be 0.25, 0.33. So they're not agreeing in the tenths or the hundredths place as well. Okay, so they did not agree. They did not agree. Not agreeing anywhere on these values. Okay, the ruler in Model 1 is not very useful, but a measurement can be estimated. It's being used, but it's not really very accurate or very precise. Discuss in your group how each student might have divided up the ruler by eye in order to get the measurement that he or she recorded. So if you do have a group there that you're working with, that's great. Otherwise, let's talk a little bit about it. Right here, you notice that Susan and Maya, they just made an estimate to the nearest unit. So they divided the ruler maybe into 10 parts. They estimated markings here, 10 markings, maybe they divided into 10 markings, and they said, I'm going to go to the nearest centimeter. Both of them measured to the nearest centimeter. Okay? Notice here that Jonah is going to the nearest half of a centimeter. So he might have divided it into maybe more markings where he was able to get to the nearest half of a centimeter. So maybe the 10 divisions and then each of those in half. So he's dividing it in, it would be actually 20 markings. Okay? And then Tanya and Dion are dividing it still in a different manner. So all of them are getting different values because of the way that they're considering this rather crude ruler to be divided in their approach. All right. Here's ruler B. Now, we don't just have 0 and 10, but we do indeed have markings in between. We've got 10 markings all the way from 0 to 10. Now we might be a little more precise in our measurement because it's clear that compared to Model 1, Ruler A, all we knew for sure is that it was longer than 0 and less than 10. We knew that for sure. It was longer than 0, less than 10, and probably you could conclude, well, it's definitely less than 5 because that's pretty close to halfway there, so it's less than 5. But we were kind of not sure, it's a little more vague. Now we have a ruler that is maybe going to be a little more helpful. Probably all of the people measuring using this ruler could now agree that this object, this metal strip here, is definitely longer than 3. And indeed, you'll notice that's what they all conclude. They're a little more in unison this time. The students obtained a better ruler. What distances can you be certain of on this ruler? Well, you know for certain you are going to be able to measure to the nearest centimeter. Okay? And you know that your object here is going to be greater than 3 centimeters. Everybody agreed on that. Okay? Or at least exactly 3. It's not going to be exactly 3, but 3 or bigger. Okay? And number 5, were the students able to agree on a single value? Yes, this time they were able to agree. They all were able to agree that this object is at least 3 centimeters. Okay? Question 6. What feature of the ruler Model 2 made it possible for the students to agree on a value in that digit? So in this one here, this ruler has spacings or has markings for every centimeter. And so this allowed the students to determine that the object, the metal strip, is greater, at least equal to or greater than the 3 centimeter mark because of these additional marks from 0 to 10 that are spaced out evenly so that you can determine that each mark is going to be a 1 centimeter interval. Okay? We have more marks, more markings. There will always be uncertainty in a measurement. Let me repeat that. There will always be uncertainty in any measurement. This causes variation in measurements even if people are using the same instrument. As we saw up here, all of these students used exactly the same instrument, but they came up with different values. Not quite as varied as up here in ruler A, but still it didn't matter. Even though ruler B is more precise, had more markings, there still was some variation. Compare the variation in the measurements made by the 6 students using the rulers in Model 1 and 2. Which ruler resulted in greater variation? And we already talked about that. Model 1 obviously has greater variation because it has fewer markings. It's less precise. And you're going to have greater variation the fewer precision, or the less precision there is in your instrument. Here in Model 2, ruler B, everybody was a little bit closer together, even though there was still some discrepancy, some variation. Model 3. Now we have a ruler that has a lot more markings, and we can be even more precise in our measurements. Now if we look here, you'll notice, as compared to up here, everybody agreed excuse me, that ruler B, using ruler B, that this strip of metal is at least 3 centimeters or longer. Everybody agreed on the 3, but not everybody agreed on the next digit in the tens place. Now we are measuring here, and here's 3 centimeters, and then you've got 1, 2, so this mark right there would be 3.2. Everybody now is agreeing not just on the 3, but also the 2, because we can see a little bit more clearly that this metal strip is at least 3.2, and maybe a little bit bigger, maybe a little bit longer, I should say. So everybody's agreeing now to the nearest, not just unit, but to the nearest tenth. Able to agree? Yes, they were able to agree to the nearest tenth value. Okay, and what feature? This time the feature is because we have more markings. We have markings that are to a tenth of a centimeter and not just to the nearest meter, or sorry, not to the nearest centimeter, or to just to the nearest 10 centimeter. Okay, more markings, more precision allows that. All right, and let's go to, we are on Model 4 now. When humans use measuring instruments, variation is expected. Remember, there's always going to be some variation. Everyone will estimate differently between marks on the instrument. On the other hand, digits that are certain based on marks on the instrument should not vary from person to person. So let me just kind of say this in different words. Everybody should be, depending on the instrument, should be certain to a certain extent. You should be certain on certain values. There should be a certain amount of certitude. I don't know how many more ways I can say that. So I think I kind of overused the word certain there, right? But you should be able to, depending on the instrument, be clear as far as certain values, certain measurements. But then there's going to be some values that you're not quite sure on, and you are going to have to estimate. You're allowed to estimate, and that's where some of the variation comes in. Okay? So let's look back at ruler A, ruler B, and ruler C and compare them all. You now know that ruler A, B, and C are all able to measure this metal strip, but with different precision, because ruler A, B, and C have different number of marks on them, different markings that allow you to be either more precise or less precise. Number 9, key point here. The measurements taken in models 1 through 3 have been combined in model 4. The measurements that follow the rules of measurement agreed upon by scientists are in the valid measurements column. Those that do not follow the rules are in the invalid measurements column. For each valid measurement shown in Model 4, draw a square around the certain digits, if any, and circle the digits that were estimated. So let me just clarify what they're saying here. What they're saying is these in this column here would be accepted by scientists as valid measurements. These measurements over here, taken by certain students, would be qualified as invalid measurements, depending on the ruler that is used. So let's analyze this. In ruler A, these two measurements, 3 and 2, are valid. Why? Because with this ruler A, you cannot measure something to the nearest tenth, let alone the nearest hundredth of a centimeter, because you don't have enough marks in between 0 and 10 to do that. You are allowed certain values and then one estimated value past the certain value. So in this case, the only certain values in ruler A are 0. You know it's greater than 0. So you are certain, all the people that measure this strip right here would be certain that it's greater than 0. And then you have to estimate the next digit, or the next number. So you can only estimate to the nearest unit, or the nearest centimeter, because you don't have enough markings in here to know whether it's greater than 2 or less than 3 or greater than 4. You just have to estimate. So these two are okay, but you cannot use those if you use ruler A. Ruler B, now we have a few more marks. Now everybody is certain that it is at least 3. This is the one that you are certain of. Everybody can be certain of that. Then you are allowed one more digit past the certain value, past the certain place value. This unit here, the units place, we are all certain about. Everybody can agree that it's 3 or greater. Now, when you're measuring, you get to estimate the next number, the next place value. And some people are going to say, well, I think it's 0.2, I think it's 0.1, I think it's 0.3. You have to guess because you don't have markings in between 3 and 4 here. You are allowed one digit to estimate. Okay? Now in ruler 3, we are certain about 3, certain, and we are certain here about this one as well, because we are pretty certain that it is 3.2, that's 3.2 right there, or greater. Everybody can agree on that. All right, so we are certain about the 3 and the 0.2. Now we are certain to 2 place values, the units and the tenths. And it is this third place value, the hundredths place value, that you are allowed to estimate. Okay? In fact, you need to estimate. You're encouraged to estimate. And some people are going to have 1, 2, or 0 in that hundredths place. And that's okay. All right? But you can't estimate out to the nearest thousandth. You don't have that precision with this ruler. That is invalid. Nor would you only estimate to the nearest tenths. You are required to estimate one digit past the certain digits. Okay? So, if we wanted to, we would say these are all certain, 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 and this is your, this would be, what did they say, to put a box around it? Sorry. Draw a square around the certain ones. Sorry. These are not certain. These are estimated. These are estimated, estimated. Estimated, estimated. These are all certain. These are estimated. These are all certain. These are estimated. Okay? Apologize for that. Estimated. These are still estimated up here because we didn't have markings on the nearest unit. Okay? So a box around the certain ones, circle around the estimated digits. Based on the examples in Model 4, circle the best phrase to complete each sentence below. In a valid measurement, you record 0, 1, or 2 estimated digits. You only record one estimated digit. Okay? In a valid measurement, the estimated digit is the first digit, second to last digit in the measurement. It is always the last digit. Your last digit is the estimated one. You can't go past that. Don't add on more estimated digits. You only are going to have one estimated digit, and that should be your final one. And in a valid measurement, the estimated digit corresponds to the longest marks, the smallest marks, 1/10 of the smallest marks. Yeah, it's going to be 1/10 of the smallest marks, because the largest marks you're certain about, the smallest marks you're certain about, but 1/10 of the smallest marks you don't know, that may not be given to you. That wouldn't be given to you. So you have to estimate that. This is the way you're estimating. Okay? Number 11, using ruler B from Model 4. Let's just go back up there and look at it. Here's ruler B. Every mark on every centimeter. Tony recorded a measurement of 3 centimeters. Explain why this was an invalid measurement. Well, in ruler B, you are allowed to go, you have to go to 3, and then you need to estimate whatever would be the measurement in between 3 and 4. You know it's 3 or bigger. Now you get to estimate, well, how much bigger? Is it 3.0? Is it 3.1? Is it 3.2? Is it 3.3? Is it 3.4? That is your responsibility to give the last estimated digit. Okay? So just saying 3 is not valid. You need to say 3.0, 3.1, 3.2, 3.3, whichever one you think is the best measurement. And the 0.1, 0.2, 0.3, that is your estimated value. Using ruler B, Dion recorded a measurement of 3.20. Again, that's invalid. Invalid because you can't go to that precision. You can't go out to the hundredths. You can only estimate to the tenths because of the markings on that ruler. Okay? When Maya made the same measurement using ruler C, it was considered valid, and that's only because ruler C has more marks on it, has more tiny marks. You are allowed to go to the nearest hundredths on ruler C, but not on ruler B. 13. A student recorded the length of a test tube as 5 centimeters. Which ruler was the student using? So this is estimated out to the nearest tenth, which means they must have been using ruler B. Ruler B because you would be certain that it is at least 5, and then if it's longer than 5, you would be able to estimate between 5 and 6. How far between 5 and 6? What would be that last digit? Okay? In Model 4, Ricky recorded his measurement 3.19 centimeters using ruler C. That makes sense. You can estimate out to the nearest hundredth there. His classmates thought he was wrong because his second digit was not 2. However, Ricky's recorded measurement is perfectly valid. It's perfectly valid because he is saying, well, it looks, all of you think it's 3.2 or greater. I think it's actually a little bit less than 3.2. So he is certain that it is at least greater than 3.1. He doesn't think it's up to 3.2. So he's going to estimate that it's 3.19, and that's completely valid as well. All right? When a measurement is recorded properly, all of the digits that are read directly, the certain ones, and the one estimated, the uncertain one, remember, you are going to record everything that is certain, and then you get to write down an estimated value, the one that you're not quite certain about. All of these digits are called significant digits. They are important in the measurement of whatever you are measuring. Okay? The recorded measurement, those are all very significant. They are important digits in that measurement. The number of allowable significant digits is determined by the marks, the precision, the gradations of the instrument. How many marks are on that instrument? Sometimes a 0 is the estimated digit and must be recorded because it's not a very precise instrument. Okay? So let's just practice here. 15. 15 says record the length of the wooden splint in the proper number of significant digits. So 15, if you were, notice you only have marks here on every centimeter. So 1, 2, 3, 4, 5, 6, 7. Ooh, that's pretty close there. Pretty close to 7. Maybe everybody might agree that it's at least 7 or bigger, but some of you might say, no, I think it's not quite 7. So some of you might say it's exactly right at 7, but then remember you get to estimate one past 7. So some of you might say 7, and I think it's 7.0. Somebody might say, no, I think it's 7.1. Somebody might even say it's 6.9. All of those are valid measurements there for this particular ruler. Okay? You get to estimate. These are all estimated. These are certain, even though we have a little bit of a discrepancy there. Okay? All right. In number 16, if you were to use the same wood splint and use a different ruler, though, this one is more precise. Now, when you measure this, you would measure to 7.00, assuming that it's exactly 7 centimeters, 7.00, because you are able to estimate to the nearest hundredth of a centimeter in this case. Okay? All right. In our extension questions, now we have an instrument. This is a scale that is going to give us the mass of an object. When using an electronic device such as an electronic balance, the measurement displayed on the screen is assumed to have one estimated digit. So notice here, your value on the mass of this object is 1.20 grams. This is your estimated. Even a digital scale like this, a digital balance, is going to be uncertain. Because there is fluctuation in the estimate, estimated digit included. In fact, you'll often see the estimated digit changing rapidly. This last 0 here might go up 1 or back down to 19. So that might fluctuate back and forth slightly because it's not certain. There is fluctuation in the estimate. Explain why it is important to record the 0 in the measurement shown to the right. So in this one here, number 17, we're going to record that 0 because it is one of the significant digits. You need to record that 0 because it is the estimated value that is allowable. It is required, actually. 1.2, the balance this instrument is pretty certain that it's at least 1.2, but then this last hundredth of a unit is uncertain, but you're still going to record it. So 1.20 grams is going to be your recorded value. All right. If you did not put the 0 there, if you just put 1.2, then they're going to assume that this instrument, that this is the estimated value, and the instrument that you're using is only accurate or estimating to the nearest tenth instead of to the nearest hundredth. Number 18, consider a 1,000 milliliter graduated cylinder with marks every 100 milliliters. So you've got it's basically a tube like this, okay? That's your graduated cylinder. It all the way to the top, it fills up and will hold 1,000 milliliters. That is 1 liter, by the way. And it has marks every 100. So 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. A student records the volume of liquid in the cylinder as 750 milliliters. Is that okay? Can he use that? Explain. Well, if you are measuring every 100, then you're allowed to estimate in between 100 and 200. Okay? So, in this case, let's say, for example, you went all the way up to 100, 200, 300, 400, 500, 600, 700, and there's 800, and you think that it's in between those. So yes, 750 would be a valid measurement. He's certain it is at least 700, and then you're estimating the next digit. Okay? The 0 is just here as a placeholder, by the way. That's just so that the 7 and 5 are in the correct location. Are all the digits in the described measurement of 750 milliliters significant? Well, the 7 is certain. The 50 is estimated. Those are definitely significant. The 0 is not significant. That is not part of the accepted digits that you can use in your measurement. It is simply a placeholder. Placeholder. That's all it does. It needs to be there so that the 7 and the 5 are pushed to the correct place values to give them the 700 value and the 50 value. This 0's got to be there only to push the 7 and 5 into the correct location. But it's not part of the significant digits in this measurement. Only the 7 and the 5 are. Number 19. A student properly records the length of a block as 120 centimeters. Draw the markings on the ruler that was used to measure the block. Okay, if it's 120, then this is your certain, the 1 is certain, and the 2 is estimated. The 0 is just a placeholder. So if you were to use this, you could have markings every 100. Let's say like this, 100, 200, and then let's say that your object that you're measuring is something like this. This is your object. And so the object, you're going to estimate the object is about 100. It's greater than 100. You're certain about that. But you know it's less than 200. But you're not sure exactly where it is between 100 and 200. So you guess on the next digit. Somebody might say it's 110. Somebody might say it's 120. Somebody might say it's 130. There's going to be variation. But definitely 120 would be used in a ruler or with a ruler where the markings are every 100 centimeters. Okay? All right. I hope that was helpful, and continue to look back at this video if you would like to. If you weren't clear about something, you can obviously go back and look at this video over and over. Maybe even look back at your inquiry activity to make corrections and learn from something that you didn't understand the first time you did it. All right, I will see you in the next video.